This is the Minimax Hub, a website that teaches the Minimax algorithm with alpha-beta printing. Lessons and challenges. When Minimax makes a move. Optimal for zero-sum games, Minimax is best suited for environments like chess, poker, and tic-tac-toe, where one player's gain is directly another's loss, making it ideal for competitive scenarios. Crucial and perfect information settings. The algorithm thrives where all players are fully aware of the game's state, ensuring decisions and strategies are based on complete knowledge, thus favored in deterministic games without the element of chance. Strategic for AI development. Minimax is key in developing competitive AI by allowing it to think ahead and simulate potential moves by the opponent. Essential in games with finite strategies and outcomes for crafting advanced strategic AI opponents. Start tutorial. Introduction to the Minimax algorithm. Suppose we have a two-player zero-sum game. One player wants to maximize, the other player wants to minimize. Minimax values, computed upward from the terminal states. Terminal values, part of the game. Okay, I see the min value takes the min out of 5 and 7. 3 and 9, 3, and then the max 5. Minimax values the optimal score that can be achieved at a particular game state, assuming both players always make the best possible moves. Alpha-beta pruning. Introduction to alpha-beta pruning. Game trees can be huge even for games like tic-tac-toe. Searching every possible outcome for optimal moves is impractical. Alpha-beta pruning comes to the rescue by eliminating needless branches, dramatically reducing the search space. This tutorial will unveil how alpha-beta pruning makes navigating these vast possibilities feasible, ensuring efficient and optimal decision-making. Okay, continue. Alpha-beta pruning. Alpha, the highest value seen so far, max nodes update alpha. Beta, the lowest value seen so far, min nodes update beta. Definition, the highest and lowest values seen along the path to that node. Alpha and beta values are only passed down, terminal values go up. Okay, I see the code to the right. In the Minimax tree, navigate through the alpha-beta pruning tutorial. We start alpha at negative infinity and beta at positive infinity. This sets a baseline that any actual score will surpass, allowing us to effectively track and update the highest and lowest scores encountered during the search. Okay, I see the values are passed down. Alpha, beta values are not updated until we see the first value. 10 is larger than negative infinity. Okay, it's a max node, so alpha is updated. The alpha and beta values that are passed down are negative infinity and positive infinity. 10, the value of the min node, gets passed down as the lowest value seen so far. Okay. Alright, here the value gets passed down, and then alpha is updated. 10 is larger than negative infinity, okay. Is beta less than or equal than alpha? 10 and 100, yes. Prune. Alright, here I see the values were passed down. 10 seen by the max node is the highest value seen so far, so alpha is updated and the value gets passed down. Okay, here 1 is not higher than 10, so alpha is not updated. And here infinity is passed down for beta. The min node with a value of 2 updates beta because 2 is less than infinity, okay. Is beta less than or equal than alpha? 2 and 10, yes. Alright, prune, great. Now I can either restart, go back, or go to quiz. So I'm gonna go to the quiz. Alright, fill in the Minimax values. Regular triangles are max nodes that select the highest value. Upside down triangles are min nodes that select the lowest value. Alright, start here. Here the max 8, 50, min 8. Alright, easy enough. And if I'm wrong, great. Alright, not so bad. Alpha beta quiz. Alright, the alpha beta pruning quiz. Here I see the same information as before with the code, and if beta is less than or equal than alpha, then prune. Okay, follow the highlighted input, enter the alpha and beta values. Click the icon if you need help and drag and drop the X to prune. Okay, I'll get a hint. No values have been seen to update alpha or beta, so I'll pass down the values. Alright, here I'll update alpha because it's a max node. I'll get another hint. Alright, so this is going to be beta updated. Here I'll update alpha to 50. I'll get another hint. Alright, so I'll pass down negative infinity and 8. Alright, I'll update alpha. Alright, see if I'm wrong. Let's pass these values down. Update alpha. Great. Now I'll go ahead and prune. Try to prune this. Incorrect, okay. Here, 50 and 8. Try to prune this. Yes, okay. And then this over here. Perfect. Let's see how I did. Not so bad. Now I can either restart. I will go ahead and go back. That's the Minimax Hub, a site to teach you the Minimax algorithm with alpha beta pruning. Hope you enjoyed.